So thanks for coming this afternoon. I'm Lindsay King. This is Peter Broadwell. We're both from Stanford University Libraries. And so I'll just get started. The ideas in this talk were sparked by a need that many of us are facing right now to comply with accessibility requirements for library collection materials that are presented online, namely by the task of creating alt text for large numbers of images. So that may sound familiar to some of you. We looked at ways that we might make that work better for cultural heritage materials than out-of-the-box and cloud-based models currently do, using some specific library collections as examples. So the technology that we employed to do this also points to other ways of making collections more discoverable, which we will return to later on in the talk. The initial question behind this set of experiments was, knowing the pros and cons of generative AI, does it even work for the task of generating alt text? The scale of digital images needing remediation makes AI approaches appealing, but does it produce accurate enough text often enough to be an effective solution? The models just keep getting better, as I'm sure you all know, and newer vision language models are performing better than captioning tools that were cutting edge just a few years ago, but there's no magic bullet, and we still do need human review. So we definitely want to think about how we deploy these vision language models and how much control we have over our images and data. So no, please don't just cut and paste your digital collections images into ChatGPT. So also thinking about what metadata that we in libraries have available for models to draw on, that really varies, but as we'll show, it can really make a difference in both creating and evaluating AI-generated alt text. So we'll begin by talking about what makes useful alt text. It is contextual, and we need to strike a balance between purely visual description and incorporating names and dates, locations, etc., that we might have in the digital collections context to help make sense of the image. So Pete's going to talk a little bit about alt text.
Okay, thanks, Lindsay. We'll be trading off pretty frequently here. Here's just some basic guidelines and definitions for alt text or text alternatives for images. The most obvious use case is to make content on web pages accessible to vision impaired individuals, but you also need alt text for video elements and graphics and images when, say, a page is being viewed over a low bandwidth connection or on a small device that isn't able to display the media. And the actual, set of formal specifications for alt text is, very thin, I would say. We'll talk about other ways to characterize what's available. But here are a couple links to some of the best practices, guides for best practices. And we'll see them in action on the next slide here. So just quickly here, these are a couple examples of sort of accepted ways of providing text alternatives for images. According to the best practices guides, you can either add the description in the image tag in the HTML, which if you squint, you can maybe see down here. And the other alternative is actually to leave this alt equals element blank, but then provide the text in an adjacent caption. The idea being that a screen reader would be able to allow someone reading through the page with the screen reader to associate that text with the image. So that comes from some of the best practices guides, but there is quite a bit of leeway with a lot of these specifications or practices. So even within Stanford, we have this range of numbers for how long a descriptive text for an image should be. Obviously, we're just talking about English at the moment. I know that there is a breakfast table tomorrow about accessibility, and maybe we can decide on a number there. I think it's actually better to be a bit flexible around these things. But you can see generally the alt text guidelines really are guidelines rather than strict rules. For this page, there's a couple interesting points we want to make, just that assistive technologies in general have been some of the earliest and arguably most successful implementations of multimodal and generative AI. So this is a screenshot of a page for it's a feature of one of the most popular screen reader software systems for Windows only that has a plugin that uses AI image generation, or image description, image description technologies, although it is sort of the same underlying thing, to describe images. And it's possibly doing it on the device, but more likely it's just round tripping the images through a commercial service like ChatGPT. And the text on this page actually describes ways of coping with the problem of AI hallucinations of the AI image descriptions, where it describes something that's not actually in the image. Say it thinks a cat is a dog or something. So it's noteworthy that in this documentation, they're not throwing the baby out with the bathwater. They're saying, generative AI image description is still considered a net benefit for accessibility, despite problems like this. So instead, the article goes into how do you best practices or ways of coping with potential hallucinations, and mentions that context is specifically important to determine whether an image description is legitimate, which is where libraries, archives, member institutions can come in. Certainly we have a major advantage in that we're likely to have access to as much context, as much metadata as would be available for an image. So one question that we were approached in the work we're talking about here is just whether we can use that contextual information to generate better image descriptions in partnership with AI. All right, back to Lindsay.
Great. So as I mentioned, we're not advocating that you just cut and paste your images into chatgpt.com just because you can. Doesn't mean you should. So there are many vision language models available. Some of them are more open than others. And Peter ran a series of tests on art images to see how they performed at creating alt text specifically. So that specific task. Comparing ChatGPT, Claude, Gemini, Florence V2, Qwen 2.5, and Gemma 3, it's clear that image captioning models with text generation components are the best at creating alt text. So newer models have surpassed the "this image may contain" classification tools that seemed impressive not too long ago. And there are, of course, some pitfalls, which we will see, that we might expect from generative AI hallucinations and what I call the padding the book report writing style. So you'll see some interesting common pitfalls across language models. They'll use the terms vintage and traditional that turn up in the text for historical materials, which we have a lot of. Generic editorializing words like ornate, dramatic, elegant, evoking a feeling of. So we'll get into how we mitigate that later on. But here I will also mention that a topic for another talk or several is how AI image analysis enables other ways of making library collections more discoverable and accessible. So we have clip language image models that can make images visually rather than textually searchable, even if they have minimal metadata. We have image feature embeddings that enable similarity search or sorting by nearest neighbors. So neither of those types of searches is available in traditional library catalogs with metadata, but embeddings of visual and textual information within semantic space to open up that interesting realm of possibilities. But anyway, that's for another talk. So back to alt text. Here's what PowerPoint's accessibility tool auto suggests as alt text for this 19th century Japanese print from the Metropolitan Museum of Art. It calls it a box with a tissue and a mouse. So you'll note that Microsoft is actively soliciting user feedback, presumably to help train their model to make it better. It's admirable that Microsoft is making alt text really easy and automatic, but clearly this tool is not going to work for art images. So let's see how some vision language models do at this task. At the top right in red is the prompt that we gave to two different closed commercial models from OpenAI and Anthropic with the same Japanese print from that previous example. So you could describe this as the prompt and pray approach. OpenAI's GPT-4 gives us exactly 120 characters, and it gets that the red characters are seals, but the title of this work of art says that the box is for holding ink. So that suggests to us that the training data included some incense boxes and burners, which would certainly show up in these online public domain image collections on which these models are trained. Anthropic's Claude gives us exactly 125 characters and gets that the box is for an inkstone, but like PowerPoint, it sees the seal as a mouse. So here's an example of an open model, Florence 2, which is a pre-trained foundation vision model that can be fine-tuned further locally to perform specific tasks. So we'll come back to that idea of a local model that you can fine-tune yourself or work on, and you know what's going on. You can control things more as you're doing them and repeat them for other people. Florence 2 can perform the captioning task at 3 levels of detail. So it's giving you the caption, the detailed caption, and the more detailed caption. It's a little wordy, but it's getting some things right. So that this was an interesting experiment to do as well. And these two cases that I'll mention last illustrate what appears to be pretty rapid progress in the development of cloud-based closed models, in this case specifically Google's Gemini family. So the Gemini 1.5 response is falsely identifying incense or an incense burner in the print, but the responses are otherwise accurate and they're under the character limit. So it's following our prompt. Like Florence 2, it's giving us three options. Option 1, most concise. Option 2, slightly more descriptive. And 3, focus on materials, and then it's telling us which one it thinks we should choose, which is maybe a little bit too helpful, but also something that we could discourage by refining the prompt. So the Gemini 2 models, which were added to our university's AI Playground cloud service while we were preparing this talk, tend to avoid both hallucinating the incense, as we've been seeing, and providing 3 levels of detail without being asked to do so. It's not doing those things. So these alt text options are both concise and pretty accurate. So if locally run models are following this same trajectory as the cloud-based models, we can be optimistic that they could be suitable for generating alt text at scale. And our next slides will then detail our investigations regarding how to get the best performance out of the current state of the art in local vision language models. So I'll hand it back to Peter.
Thanks, Lindsay. Yeah, so as we've seen, there are good reasons to consider using vision language models for describing and possibly making images more discoverable and accessible too. And also, it seems local models might even do the trick as their abilities continue to improve and approach those of the cloud-based models. So we've just seen, one example image and a bunch of captions, but throughout the rest of the talk, we'll be describing the results of some larger scale experiments that we've been running on different collections of images. So again, there is always the question of using cloud-based commercial models versus locally hosted open models. In the case of the cloud-based models, the per token cost, the image or per image or query cost can get impractical for large collections, especially. There's also the downside of the changeability of the services, which sort of limits reproducibility. This came up in another session earlier today. It was great to be echoing some of those previous conversations from our earlier session. So the cloud services are generally always improving, which is great, but it does make that repeatability difficult, as the model that produced a given output yesterday may not be available today. There are also concerns, obviously, about the privacy and custodial implications of uploading your bespoke image collections to a company, especially when the company's business model is kind of based on getting a whole lot of content and learning from it, and not worrying too much about whether some of that content might leak out later in responses. So again, that's another reason to consider these promising local vision language models. So as Lindsay mentioned, we've run some various experiments to see how we can get these, especially local models, to behave the way we want. And the general approaches available to us is, first of all, fine-tuning, which is kind of the classical machine learning approach to altering a model's behavior. You give it a bunch of examples of images and the caption we want it to produce. This is especially desirable if, you're noticing a model is generating a presentist bias or exhibiting a presentist bias. It's a bit too much for the collection that you're working with, especially if it's a historical collection. But what we actually focused on the most, or spent the most time investigating, was this idea of prompt conditioning, which is a more recent ability that really came to the fore when chatbot models, and for especially LLMs and also now VLMs, vision language models, became available, and particularly the instruction following versions of those models emerged. And especially the ones that we can run and fine tune out locally. So in that case, you can give the model natural language instructions in the prompt that can be customized for each item, so that you're sort of dual conditioning the caption that you're getting with both more input text and the image itself, obviously. So we conducted experiments with some public domain images and also our own image collections, and specifically using the model Qwen 2.5 from Alibaba and Gemma 3 from Google. And we'll describe some of those results in the rest of the presentation. Mostly focusing, again, I said, on prompt conditioning. The reason why we didn't do so much of fine tuning, even though we did test it out, we're not going to talk about it too much, is that again, it can be generally a slow and expensive process. And also, as we discovered, even if you have any metadata about the items you want to caption, it may not be sufficient for fine tuning, but actually it could still be useful for prompt conditioning and can be incorporated productively that way. So here's some examples of what prompt conditioning involves. So we're tailoring, in this case, we're tailoring the specifics, the prompt to the specifics of a single collection, which gives us better results than trying to apply the same overall approach to prompt to multiple collections. So here we have the system prompt, which is the same for all the items in the collection. This tends to be right now, given the way the technology works, where you try to discourage certain behaviors, like as Lindsay mentioned earlier, describing. If you notice that the model tends to be describing, using some cliched phrases you don't want it to use, and you can discourage that here. We also just included a bunch of instructions from these best practices guides for alt text that we mentioned earlier in the talk, some of you have probably seen this already. In addition to instructions like this, you can actually provide examples of captions in this kind of prompt. That's often referred to as in-context learning, although we don't have an example of that here, but that's something that is pretty prevalent these days. And so here's just an example of how then the user prompt, which in this case is the prompt that's tailored to every specific image, what that might look like and how it can incorporate available metadata. And as we discovered, this tends to generate better alt text, even when the metadata is kind of messy and not so easily integrated into, grammatically perfect English for the prompt. The model can still use it. And now we will share some more examples of captions that we produced, specifically using the Qwen 2.5 vision language model, the 7 billion parameter instruction following version. There are lots of flavors of these things now. And we compared the results specifically between the caption that the model produced when it's just given the image and a very generic prompt like, hey, please write alt text for this image, versus when we do the dual conditioning with actual metadata that's available for the image. So here's a quick example from a collection of Japanese prints from the Library of Congress that already includes short descriptive captions supplied by humans, which we can either include in the metadata or not for evaluation purposes. Or that is, we can either include in the condition prompt or not. So you can see that we get kind of a nice synergy of the visual object recognition. The image only from the model notices that there's an umbrella, which actually the human description doesn't include. But the human description, does provide some details that the image description itself is missing, and then the fact that it's an American soldier. So we get a nice sort of combined collaborative outcome here for the alt text. And now Lindsay will walk us through a few examples from collections at Stanford.
Great. So this example is from the Doug Menway's photography collection at Stanford Libraries, and that already has short descriptive captions. So there's some human-supplied text that is more informative than the model-generated text in some ways, but the combination that's shown on the far right here arguably describes the image better than either of those things individually. So the human caption gives us information about the situation being photographed more than what's actually pictured. And then the model describes the people without knowing who they are. And so if we put them together, the combination tells us both who is pictured and what they're doing. So the combination gives us Steve Jobs and Canon executives gather for a toast, June 1989, ahead of Canon's $100 million investment in Next. So that is what someone who can't see the image would actually need to know. Here's another example from the Doug Menway's collection. The human-supplied caption describes the location where Menway's took the photograph, but not really what's pictured. So again, the combination is an improvement as alt text, close-up of Next computer motherboard at the Fremont manufacturing facility. So a different collection, in this example from the Wiley Wong collection of May's studio photographs taken in San Francisco's Chinatown, the human-supplied description gives us the medium that makes this image unusual, hand-colored photographic print embellished with glitter, as well as the information that this is an actor in costume, whereas the model describes the image as a vintage portrait of a woman in traditional Chinese attire. The combination gets us portrait of an actor/actress in traditional Chinese theater costume, hand-colored and embellished with glitter. So again, pretty good alt-text caption. In another image from that same collection, the original human description says Grant Avenue, Chinatown, which gives us place information but not much visual context. And in fact, the model then reads the text on the bottom edge of the photograph that places the image in SF Chinatown. So this is an example of what we were saying about the model having a presentist bias, because it labels this as a vintage street view with historic signage, which of course would not have been accurate when the photograph was actually taken. But vintage street view of Grant Avenue, Chinatown, San Francisco, with historic signage and architecture is not too bad as alt text. So, looking ahead, this has been a pretty brief overview of the problem space facing libraries and museums around making online image collections accessible. We've presented some experiments with using vision language models for the alt text task that is facing a lot of us. So we're not proposing that you do exactly what we did, but the dual conditioning strategy may be the right approach for the really varied collections that we have in cultural heritage institutions. For every library, the question of how to incorporate AI-generated alt text in online exhibits or image collections will be different.
Yeah, and I'll just tell you what's going on here a little bit. This is just an example of how an alt text editing or input workflow might incorporate suggestions from vision language models. So in this case, we're just using sort of a batch spreadsheet-based curatorial approach that should be familiar to a lot of you. Yeah. And so to continue on our wrap up here, again, so some questions to consider are that I hope we've at least provided some initial ideas about would be, how a tool that enables AI generated alt text would need to function in your library's image environment. There's questions, certainly questions about quality assurance are important to address. We used a few different approaches here, including having some ground truth that we were comparing the generated captions against. In other cases, you might just try to do sort of random spot checks, but given the scale of the collection and the potential danger of hallucinations, it's definitely right to ask whether that's sufficient. Another approach, in the session earlier today, there was a discussion about how difficult it is to, and the actual science of benchmarking language models and AI models is still evolving. The idea, but one approach that is somewhat that has emerged and is somewhat getting a lot of traction these days is to just use a different vision language model to check the output of the first one. So have the robot evaluate the other robot. Yeah, and that might be the best way to go. But as the landscape of assistive technologies continues to evolve, we still need to continue to think about, and just all of these technologies continue to evolve incredibly quickly. We need to keep thinking about how library systems can adapt and actually, use these technologies as effectively as possible to serve users. So that's kind of the point we keep coming back to is just how to be thoughtful and responsive to these developments and use the best technologies we can apply to this task. There are also some benefits from universal design that might apply here too. The fact that we're using these text-to-image models to generate captions means we can also use them to generate embeddings that, again, we can use for other modes of enhancing discovery and access within the digital library collections. So that's the end of our presentation. Thanks for coming, and we have a little bit of time for questions, I think.
So there are some mics in two spots if anybody wants to come up and ask a question. And we will also hang around into the next break. Yes.
Not pushed to, if you're not pushed to do it fast, like now, should you wait? And are we also getting to the point where our browsers are going to do this for us anyway? Kind of like machine translation. I don't know. I just got a Dutch article this morning and they didn't bother to translate it because, duh.
Yeah, we were thinking of those things too, but I think So you need to be able to be adaptable. If you're going to roll this out in a library system, you don't want it to be something that you're asking people to spend tons of time on and then it changes and they have to do it again. But we did think of that. I think part of what we're trying to say here is that there are ways of improving the response or improving the outputs of these kind of AI-generated tools. So there's variability in what you'll get. So we could do, like you could put your Dutch article into Google Translate, but maybe it wouldn't be quite as good as if it was something that was more tailored. So, pluses and minuses.
Yeah, I'll just add, those are really great questions. One impetus for us is that accessibility mandates are already out there. And so the sooner we do this, the better. We can always fix it later, or not fix it later, but we can improve later. Or if something an on-device option becomes available, certainly that would also just be a good complement to what we're doing. And also, as we alluded to, there are other, given this universal design option that we can get embeddings from the same models, and we can use those for other kinds of accessibility improvements. At least suggest to us that it's worth pursuing the technology now, but also with an eye towards the understanding that things might change very quickly, and we might have to as well.
Hi, Lindsay, Peter, thanks so much for this presentation. This is really interesting work. I'm wondering a little bit about some of the ethical dimensions that you encountered in doing this work. Holding sort of accessibility requirements as sort of that kind of standard, pushes you in a certain direction. And I noticed that when you were, sort of conditioning those prompts, that you were talking about eliminating sort of ethnicity or identifying age or anything like that. And thinking more broadly about the types of collections, and here, I've done a lot of work with protest photography, right? So thinking about the types of collections that you're using for algorithmic processing, just wonder if you might want to speak a little bit to that as well.
Well, that's a great question. These are locally run models. So that's one reason that we would say don't put these things. We're not just uploading our library collections into ChatGPT, thinking about those concerns, but also knowing that there are these pitfalls of generative AI that we still need. We're not just going to put them directly into the library catalog and say, here's your alt text, but we need to keep the human in the loop. And then this kind of approach lets us check to see what's happening and then sort of engineer what will come out as a result, knowing that those kinds of things may happen. So you did see that in the prompt, that we're trying to have it not do some of the things that AI can do when it's trying to be helpful.
Yeah, and I would just say, and some of those prompt elements are from us, and some of them are from the best practices for alt text specifically. But as we saw, the model is happy to provide different options. So we could have one model for alt text description and have another model for more general captioning that might be used in different contexts. Although we'd still need to be careful about what text it's actually producing in either case.
Yeah, thanks.
Fantastic research. In your process, did you involve accessibility experts or impaired individuals themselves to help you judge the quality of the statements that were produced? Thank you.
That's a great point, too. We started with our Stanford Office of Digital Accessibility and their guidelines. And then Peter was mentioning some of the assistive technologies that already exist. But yeah, what is actually helpful, and thinking about technologies that people are adopting, assistive technologies, the people who actually use these technologies all the time are the ones who are going to start, they'll be telling us what they want. And so that's, I guess, why I also said we have to be really flexible with this so that we're not kind of like committing our entire library system to doing it one way and then finding out it's not that helpful. So to be able to be flexible, but absolutely, that's a great point. So when everybody is trying to figure out how to supply alt text, bring in some actually like people who are using screen readers and say, does this work for you? Or is it totally nonsense? So yeah, that's a great point. I think we're just about out of time, but we're coming up to a break. So we're happy to hang around and answer more questions.
I was wondering if you could speak on the hardware that you use to process these. Mostly, I'm just kind of curious on if you have to have big hardware to run the models accurately, and how those scale between lighter and heavier models. Thank you.
Right. Yeah. That's a great question. I mean, the good news is that it's getting easier and easier to run pretty big models on commodity hardware that's available. We do have this. There are some links to the software that we use. You can see the models that we used in the presentation. That's not here, but basically, we could run it on this using a ported version of Qwen 2.5. This is just a MacBook. But we did use for bulk processing. We did use a fairly well resourced NVIDIA Dell tower with an NVIDIA A6000 card. But that was basically for bulk processing to kind of speed up the process. Yeah, and it was even a quantized model, and in that case, they were comparable. But again, QA is important in that case to make sure it's really true. It's not always going to be true for every model, but it was for that. Yeah. All right, I think we should wrap up. So thanks everyone.